This is first lecture on projectile motion. This is a basic lecture wherein we'll derive the basic formulas and understand the fundamental of the projectile motion. But before we do that, it's worthwhile looking at this chart wherein we know in entire dynamic study scenario where does projectile motion lie. So in dynamics there is kinematics and kinetics. In each of them there is particle and rigid body motion, and in particle there is we have this projectile, which is the objective of this video. Now when we try to define projectile motion, we can say that this is a motion given to a particle in this manner. Like, see, particle is considered origin, and from there it is given some initial velocity u at some angle alpha with x-axis, and then on it is left to move against or in favor of gravity. So essentially what happens is this, see, initially the particle has velocity component in x direction, which if its velocity is v, we can say it's v cos alpha, and it has velocity component in y direction, which we can say is v sin alpha. And with these initial velocities, under constant accelerations, particle is simultaneously moving in x and y direction. So it is essentially the combination of two straight line motions, one motion being in x direction and one motion being in y direction. So as it travels, see what happens. All the while it has a horizontal velocity, which is v cos alpha, and all the while it has vertical velocities, which is v sin alpha. But what happens is, when the particle is going up, v sin alpha goes on reducing, because see, gravitational acceleration is pulling the body down when the particle is pulling this particle down when the particle is trying to move up. So v sin alpha goes on reducing. At the highest point, v sin alpha becomes 0, and then when projectile or this particle starts falling down, v sin alpha goes on increasing, and finally when it comes to its original level, that is x-axis, we find that it gains v sin alpha again, same value as with which it started, but in opposite direction, and throughout the motion, mind you, v cos alpha, the horizontal velocity of the projectile, remains constant, and whole operation is happening only under gravitational acceleration. There is no other external acceleration, mind you. Just to give example, if you are traveling in a plane, and when plane takes off, mind you, you have initial velocity and it takes off at an angle alpha, some angle, but it's not a projectile motion, because during the flight you can change acceleration of the plane, and so this is not a projectile motion. But God forbid, but suppose something falls from the aircraft, then that particle which is falling off the aircraft travels only under gravity, and that is projectile motion. So these fundamental thing, that projectile motion acceleration, it only moves under gravitational acceleration, and in horizontal acceleration, velocity of the projectile is always constant, because there is no acceleration in horizontal direction. These are the few fundamental things which one has to remember. Now, there are various type of problems which we have to do for exam purpose under this topic of projectile motion. And one of the types is projectile starts from a level, say x-axis, and comes back to the same level, that is again x-axis. So for this special flight, standard formulas are derived, and these formulas are derived from these basic kinematic equations. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2s. It is expected that these equations are learned in some previous course. Just to refresh your memories, these equations are for a particle motion which is in a straight line, which the constant acceleration, particle starts from origin with initial velocity u. And knowing these parameters, what these equations give is the distance traveled and the time required, and their interrelation with each other through these three equations. So these three equations will be used for projectile motion for the simple reason that projectile motion is essentially simultaneous motion in the x direction and y direction. Now the standard formulas or the standard parameters for which the formulas are derived are: what is the maximum height h the projectile will go? So it is u square sine square alpha by 2g. Mind you, anything in projectile you will have in terms of u and alpha, because that is your initial parameters, and g is the gravitational acceleration. So u, alpha and g, all the expressions you will be able to work out if you know value of u, alpha and g. So this is h is the maximum height of the projectile. Now total time of flight t is another parameter of interest. So there is a formula for that. Total range of projectile, that is total horizontal distance which projectile travels, is r, and time required to reach the top, that is half the flight, is given by t1, and we have expression for this. And also at any point during the travel, if you want to know the projectile's position, then you have expression for x as u cos alpha t, and you can find expression for y, and eliminating these two you can come up with expression, the relation between x and y, the xy coordinates of the projectile. Now our first objective is to derive these equations, and that's what we'll be doing in the next two slides. So let's start. Let's set up a projectile with initial velocity u at an angle alpha, and is going to travel under gravitational acceleration g. Now let's say I am interested in finding the maximum height h to which the projectile will go to. So I am going to use v square is equal to u square plus 2as in vertical direction, and therefore at height h, v, I'll take it 0, because mind you, in vertical direction, at maximum height, vertical direction of velocity has to be 0, because that's what we mean by maximum height. It can't go any further. So v is 0. U is substituted as u sine alpha, because that's the vertical component, and a is g here, and minus because a particle is trying to go up and g is pulling it down. So you have your expression, the expression for the first parameter, that is maximum height the projectile reaches to, and that is u square sine alpha by 2g. Now suppose I want to know time it takes to reach maximum height. No problem. Use v is equal to u plus at. V will be 0 by the similar arguments. Use u sine alpha. Call this time as t1, and you have your expression for t1. That is half the time, or time required to reach the maximum height, which is u sine alpha by g. And see, if it requires time t1 to reach top, obviously in same time it will come down, and therefore if you are talking about the total time of flight, then it is simply twice of t1. Now let's say we are interested in finding range r, that is horizontal distance. What you use is, use s is equal to ut plus half at square in the horizontal direction, In horizontal direction, initial velocity u cos alpha t, we substitute total time of flight, which we just derived. And if you substitute t in r expression, you will get r is equal to u square sine 2 alpha by g. Here, mind you, the plus half a t square term is not taken because a is 0 if you are writing this equation in horizontal direction, because projectile travels only under gravity. So horizontal direction there is no acceleration, and you have this expression for r. Finally, let's say you have a point on the path of the projectile and whose coordinates are x and y. So if I want to find x, I'll use s is equal to ut plus half a t square in x direction. At point A, we find x is equal to u cos alpha t if t is the time it takes to reach point A. And similarly, y is equal to, again using s is equal to ut plus half a t square, you have y is equal to u sin alpha t minus half gt square. And if you substitute this t in this expression of y, we get relation between y and x, eliminating t. And this is actually the equation of the curve. And you see x square term out there, it means this path equation tells us that it's a parabolic path. So see, these are the standard equations very often used if you have this type of problem in the projectile motion. Thank you.